Today's notes are on graphing absolute value equations in two variables. The first thing you need to know is the standard form of an absolute value equation. That is y is equal to a times the absolute value of x minus h plus k. The parent function of this is just y is equal to the absolute value of x. And the basic equation adds an a in front of the absolute value symbol. Transformations are going to talk about how the parent function changes. If the a value becomes negative, it will reflect the graph over the x-axis. If the absolute value of a is greater than 1, your graph will be narrower than the parent function. If the absolute value of a is between 0 and 1, the graph will be wider than the parent function. If the h value is positive, that means your function is going to be moving to the left. If h is negative, your function will be moving to the right. If k is positive, it moves up, and if k is negative, it moves down. Notice that the k's are what you would expect. The plus moves you up, the minus moves you down. The h's are kind of the opposite. I would think that plus would move me to the right, but in this case it moves me left. Your steps for graphing is to first decide if your graph is going to open up or down, and that is based on the a value. If a is positive, it opens up. If a is negative, it opens down. Then you will find the vertex, which is the point h comma k, and you will solve what's inside the absolute value, the x minus h, for h, and then you're going to use the k value. Then we're going to use the a value as the slope of one side, and then we're going to use symmetry to reflect it to the other side. Before we look at graphing, let's see what happens when we're just describing the transformations. So for example 7, it says find the vertex and describe the transformation the equations have from the parent graph. Alright, so the first thing I need to do is find the vertex. So to do that, I'm going to take whatever's inside the absolute value, and I'm going to set it equal to 0 and solve. So I get x equals a positive 3. So that's my h value. And my k value is the 4. So the vertex is the point 3 comma 4. Then I need to describe the transformations the equations have from the parent graph. First, because the absolute value of 2 is greater than 1, I can say that the graph will be narrower. And then because of the h and k values, I can say that the vertex will move right 3 because of the x minus 3, and up 4 because of the plus 4. Please pause the video and see if you can do number 8 on your own. When you're done, go ahead and look at example 9. The first thing I have to do for example 9 before I try and solve it is to put it in the standard form, which means I need to move the k, or the 2, which is my k value, to the end of the equation, giving me y is equal to negative 2/3 times the absolute value of x plus 4 plus 2. This gives me my a value, my h value, and now I have my k value. So my vertex I'm finding by setting x plus 4 equal to 0. So I have negative 4 as my h value and positive 2 as my k value. I'm also going to make a note that my graph is going to open down because the a value is negative. And my slope is going to be the a value, so it's going to be negative 2/3. So I'm going to start at negative 4, 2. And I'm going to use the slope -2, 3, which means I fall 2, run over 3, fall 2, run over 3, and I'm just going to continue this pattern until I have a few points to graph. Then, to graph the other side, I'm going to use symmetry, so I'm going to fall 2 and run 3 in the other direction, fall 2, run 3 in the other direction. And absolute value graphs have a V shape to them, so I'm going to connect my points to form a V shape. Take note in example number 10 of your A, H, and K values. Then please pause the video and try and graph number 10 on your own. We will talk about it tomorrow in class. The next part of the notes talks about writing equations of linear inequalities and absolute value equations. The first two graphs are linear inequalities. We know this because of the shaded region. And the third graph, number 13, is an absolute value. We can tell this because of the V shape. So the first thing for number 11, I'm going to make note that this is a horizontal line. So I know that I'm going to have a variable of y, and that I'll be using some kind of inequality sign, and that all of the y values on this graph are -2. I then want to look at the graph. I notice that all my y values are greater than -2, and because this has a dashed line, I'm going to use greater than, not greater than or equal to. So my final answer is y is greater than -2. Please try and write the equation for problem number 12. Make sure that you start by finding your slope and y-intercept, and then plug into the equation y and then mx plus b, where the equal sign will be replaced with one of your inequality symbols based on the shaded region. So try that one on your own, pause the video, and then look at number 13. 13 is our absolute value graph, so it is in the form y is equal to a times the absolute value of x minus h plus k. And I'm going to identify some parts here. So the first thing I'm going to find is the vertex, which is at the point 1, -4. I am then going to find the slope, which takes me up to over 1, up to over 1. So we can note that the vertex was our point h comma k, our slope was our a value, and I know that it's positive because it opens up. So I'm going to use all of this to plug into my formula. We're going to have y is equal to our a value, which is a +2, times the absolute value of x minus the h value, which is 1, plus k, which is a -4. So this is the equation of our absolute value graph. Next, we're going to look at writing an equation or inequality given a set of information instead of a graph. So we're going to look at example 14. Note that I'm still going to be using the same formula. And it says that we're going to write an equation with a vertex of 4, -2, and it contains the point -3, 0. So I don't know my a value, but I know h, k, x, and y. So I can plug all of those into the equation and solve for a, similarly to how we solve for the b value in our slope-intercept equations. So I have 0 is equal to a times the absolute value of negative 3 minus 4. And instead of k, I'm going to use negative 2. So we're going to go through and simplify inside the absolute value. Then I'm going to take the absolute value of negative 7. Absolute value of negative 7 is a positive 7. The absolute value symbols work similar to parentheses, so it's being multiplied to the a. So this simplifies to 7a minus 2. So if I add 2 to both sides and then divide by 7, I get an a value of 2 over 7. And I can then take this information and plug it into the equation for an absolute value. So I have y is equal to my a value, which is 2 over 7, times the absolute value of x minus h plus k. So just like our slope-intercept equations, you're going to plug everything back in the end except for x and y. Please try example 15 on your own. This is a linear inequality, so it should be similar to our slope-intercept equations that we were writing, only you'll be replacing the equal sign with some kind of inequality symbol. We will talk about 15 tomorrow in class, as will we talk about 16. Please try 16, see if you can at least set up the equation, and we'll go through it tomorrow.